Okay, so today we'll start with another problem. Okay, so in the previous video we have understood to solve the frictional problems when there is only one body. Today we'll see the frictional problems with two bodies, that is a body resting over other body or if the two bodies are connected to each other. So first we'll start with the problem where a body is resting over another body. Okay, so the problem is block A weighing 1000 Newton rests over a block B which weighs 2000 Newton as shown in the figure. So block A is 1000, block B is 2000. Block A is tied to a wall with a horizontal string. You can see here this is a horizontal string. So block A is tied to a horizontal string. If the coefficient of friction between block A and B is 0.25, the coefficient of friction between block A and block B is 0.25 and between B and floor is 0.33, between B and this floor is 0.33, what should be the value of P to move the block B? Okay, there are two conditions, when P is horizontal and when P is 30 degree with horizontal. So first case, so this one is the first case when P is horizontal, this one is second case when P is 30 degree to horizontal. Okay, so first we'll start we'll start with when P is horizontal. When P is horizontal. Okay, so now body A is resting over body B. Okay, so first we'll consider a free body diagram. So let this be body A. Okay, let this be body B. Right, sorry, let this be body A and let this be body B. Okay, now we all know that, so once again, x-axis, y-axis, x-axis, y-axis, right? So now first we'll consider body A. In friction problems, when we are dealing with this kind of problems where the bodies are connected to each other or a body resting over another body, we need to consider each body separately. We need to consider each body separately and then we have to draw the free body diagram. So when you consider block A, we all know that weight will be acting vertically downwards, right? This is W. Okay, and there is a contact surface here which is perfectly horizontal, so we'll get perfectly vertical normal reaction. So this is normal reaction, we'll call this as N1. Okay, now there is a string here, so we all know that in a flexible material, in mechanics, in flexible materials there always exists a tension force. Tension force means acting away from the joint. So this is this, so this will be a tension force, we'll call this as T. Now even though P is applied here, okay, that means the motion is in this direction, but when we are dealing with this kind of problems we need to consider each body separately. So now we have considered only body A, that now tension force acting in this direction, that means frictional force always acts in the opposite direction of the motion of the body. If the tension force is here, the motion is in this direction, that means frictional force acts in the opposite direction, we'll call this as F1. Okay, remember when we are dealing with the problems like this, okay, we need to consider each body separately and then we need to draw free body diagram. So weight is acting vertically downwards, normal reaction acting vertically upwards. This is very simple and it's very clear. Now there is a string here, that means in string there exists tension force acting away from the joint, so this is tension force. Now the tension force acting in this direction, that means motion is taking in this direction, so we can assume the motion is taking in this direction. Okay, so frictional force always acts in the opposite direction, so this is the direction of friction, F1. Similarly, now we'll come to body B. Similarly here, weight is acting vertical downwards, let this be WB, let this be WB. Okay, so normal direction acting vertically upwards because there is a perfectly horizontal contact surface, so we'll call this as N2. Right, now we are dealing with a case when P is horizontal, so this is the direction of P. Now P is acting in this direction, that means motion is taking in this direction. Remember, we are considering each body separately. Okay, when we have considered body A, there is a tension force here, that means the body is moving in this direction, that therefore frictional force acts in the opposite direction. Now we have considered body B, okay, P is acting in this direction, that means motion is taking in this direction, right? So frictional force acts in the opposite direction. Okay, if you remember, at the starting of the notes I have clearly told you, okay, in the starting of the notes I have clearly told you, when two bodies are in contact, okay, we need to indicate, right, we need to indicate frictional force at every contact surface opposite to the direction of the movement of the body, okay. That means now this is a body B, right, there is one contact surface here, that is B end floor, and another contact surface between A and B. So we need to indicate frictional force at every contact surface, right, in the opposite direction of the movement of the body. So motion is taking in this direction, that means frictional force we need to indicate here in the opposite direction. So now this is F1, this is F2, okay. Any other force acting? This is applied force, weight, normal reaction, F1 and F2, okay. Now see here, the body A is resting over body B, that means the weight of the body A get transferred to in the body B, right. So in general what we have, if here there is an inclined force, assume that, once again you can see here, if this is a body, if this is body B, if somewhere there is a tension force like this, okay, now its component will be vertical, one vertical here, one horizontal here. So now in this case when you consider body B, okay, this vertical force, this T, if this is theta, this T sin theta as well as its weight, okay, and this normal reaction, okay, will be acting here. So in general what we can say here, that summation of vertical forces which is acting on body A, summation of vertical forces which is acting on body A will be transferred to body B. Simple, right? Summation of vertical forces acting on body A is nothing but normal reaction, that is N1. So N1 will transfer to body B. So this is N1 also here, you can indicate N1, okay. So P, F1, F2, W, N2 acting vertically upwards, N1 acting vertically downwards, because summation of vertical forces which is acting on body A will be transferred to body B, okay, will be transferred to body B, okay. So this is the free body diagram, okay. Okay, now first we'll consider body A, okay. Now we'll consider body A and write the equation, okay. So first condition, summation of horizontal forces is equal to 0. Summation of horizontal forces is equal to what? Simple, T is acting here, F1 is acting here, so minus T plus F1 is equal to 0. That implies T is equal to F1. We'll call this equation number 1. Equation number 2, summation of vertical forces is equal to 0. Summation of vertical forces is what? N1 acting vertically upwards, WA acting vertically downwards. So plus N1 minus WA equal to 0. N1 is equal to WA, WA is equal to 1000, weight of body A. You got the value of N1. So third condition, we know that mu is equal to F by N, or you can write F1 by N1. So from this, F1 is equal to mu between body A and body B is given as how much? 0.25, right, 0.25. So this is 0.25 into N1 is 1000, so F1 is equal to 250 newtons. So from equation number 1, T is also is equal to 250 newtons. T is also is equal to 250 newtons. Okay. Second, we'll consider body B. So consider body B. First condition, summation of horizontal forces is equal to 0. Right. Now we have considered body B. Summation of horizontal forces is equal to 0 plus P. Right. Minus F1 minus F2. Okay. If you want, I can draw the coordinate system here. See here, I am drawing the coordinate system. X-axis, Y-axis. Right. So P is acting along positive x-axis. So P is acting along positive x-axis. F1, F2 acting along negative x-axis. So I can write here F1, F2 acting along negative x-axis. Weight of the body WB acting vertically downwards. N2 acting vertically, you can see here N2 acting vertically downwards. Sorry, N1 acting vertically downwards. So N1 and N2 acting vertically upwards. So N2. All the forces here. Now we can write this equation. First summation H equal to 0. that is plus P minus F1 minus F2 is equal to 0. So we can write P is equal to F1 plus F2. This is from summation of horizontal forces is equal to 0. Second condition, summation of vertical forces is equal to 0. So plus N2 minus N1 minus WB is equal to 0. So N2 is equal to N1 plus WB. N2 is equal to N1 is equal to how much? N1 is equal to 1000. WB is 2000, so totally 3000. So N2 is equal to 3000. Third condition, mu is equal to F2 by N2. Mu between block B and the floor is given as 1 by 3. So 1 by 3 or 0.33, both are right. 0.33 is equal to F2 divided by N2. So from this equation, F2 is equal to 3000 into 0.33. So F2 is equal to 1000, nearly 1000, or you can write 1000 newtons. Okay, now you got the value of F2, you know the value of F1. So from this equation, P is equal to F1 plus F2. So P is equal to 250 plus 1000, 1250 newtons. This completes the first part of the problem. Okay, now we'll go for the second part of the problem, when P is 30 degree with horizontal. Okay, that is this one, when P is 30 degree with horizontal. So first we'll consider BD of body A. So similarly we know that it's same to the previous problem. So similarly here, first weight of body A, that is WA, acting vertically downwards. Normal reaction will be acting vertically upwards. We'll call this as N1. So there's a tension force here, remember. So okay, there is a tension force here. So T acting like this. So T, there's a tension force acting in this direction, that means body is moving in this direction. Frictional force acts in the opposite direction. We'll call this as F1. The first part is over. Next we'll consider free body diagram of body B. Okay, let this be your x-axis, y-axis. Now P is acting like this. Okay, when P is, this is P, angle is 30, right? So there are two components, we know that. That is first component, this is P cos 30, and here it will be P sin 30, P cos 30 and P sin 30. Weight of the body WB acting vertically downwards. Okay, now motion is taking in this direction, that means frictional force acts in the opposite direction. Okay, so if P is acting like this, the motion is taking in this direction, right? So now if motion is taking in this direction, frictional force acts in the opposite direction. So now we know that we need to indicate frictional force at every contact surface, opposite direction of motion, F1. Okay, so now this is free body diagram of block B. Okay, so this is P cos 30, this is P sin 30, F1, F2 force. So we need to indicate frictional force at every contact surface, opposite direction of the motion. So weight is acting vertically downwards, and normal reaction. Okay, so you know that normal reaction will be acting vertically upwards. This is N2. As body A is resting on body B, okay, we know that as this body A resting on body B, summation of vertical forces which is acting on body A will be transferred to body B. Summation of vertical forces on body A is nothing but normal reaction of body A. So that is N1 or NA. So this is N1 acting vertically downwards. If you draw, again first we'll consider body A. So first we'll consider body A. First condition, summation H equal to 0. So from summation H equal to 0 we can write T is equal to F1. Second condition, summation of vertical forces is equal to 0. So N1 is equal to WA, and that's equal to 1000. So third condition, mu is equal to F1 by N1. So F1 is equal to mu into N1. Mu is 0.25, N1 is 1000. So F1 is 250. So from this equation we can write T is equal to 250. This part, that is first part, will be same as the previous. Now we'll consider body B. So I will draw a coordinate system here. So x-axis, y-axis, right? So p cos 30, p sin 30. So this is p cos 30, p sin 30, right? And weight WB acting vertically downwards. Similarly, summation of vertical forces acting on body A, that is N1 acting vertically downwards, N2 acting vertically upwards, frictional force F1 and F2 acting along negative x-axis, so F2 as well as F1. Okay, now we'll write summation. First condition, this is for body B, summation H equal to 0. You can see here F1 minus F2 plus P cos 30 is equal to 0. So from this side we can write P cos 30 is equal to F1 plus F2. Second condition, summation of vertical forces is equal to 0. So vertical forces we can see here minus N1 minus WB plus N2 plus P sin 30. So first I will write plus N2 plus P sin 30, okay, minus N1 minus WB is equal to 0. So N2 is equal to plus N1 plus WB. N1 is what is the value of N1? N1 we got it as 1000, right? WB is 2000. So totally N1 plus WB is 3000. 3000 minus P sin 30. So what is the value of sin 30? Sin 30, we know that sin 30 is 0.5, right? Sin 30 is 0.5. So N2 is equal to 3000 minus 0.5 UP. Okay. Next, third condition, we know that mu is equal to F2 divided by N2. Okay. Mu is equal to F2 divided by N2. So what is the value of mu given? Mu is given as 0.33. So F2 is equal to 0.33 into N2. F2 is equal to 0.33 into N2. Here we got the value of F2. Here we got the value of N2. Okay. So from this equation, that is P cos 30 is equal to F1 plus F2. Okay. So you can see here P cos 30 is equal to F1 plus F2 is 0.33 into N2. Okay, now P cos 30 is equal to F1 plus 0.33 N2. This is from this equation. Okay, now P cos 30, we'll write it as it is. F1 is 250 plus 0.3 into N2 is equal to what? N2 is equal to 3000 minus 0.5 UP. So if you solve this equation, P cos 30 is equal to 250 as it is plus 0.33 into 3000, that is 3000 divided by 3 is 1000 minus 0.33 into 0.5. So 0.33 into 0.5 is 0.165p, 0.165 up. So if you just take it this side and solve this, you will get the value of p as 1212 newtons. Okay, and put the value of this p in this equation. Okay, you will get the value of F2 as 798. And this completes the problem.